5.6 Complex numbers. A complex number contains both imaginary and real numbers. The standard form, a plus bi, where a and b are real numbers and I is imaginary, I standing for the I in imaginary. An example would be 3 plus 2i, where 3 is the a and the plus the 2i is the plus bi. They're always written in this form. Another example would be 0 plus 6i. The 0 is the a, and the plus 6i is the plus bi. Now, since we're adding 0, we don't even have to show that. We could just write this as 6i. But just be aware if you see that there is a 0 plus the 6i there, because later on you will have to use this information. Before we go ahead and add and subtract, let's go ahead on the right-hand side and do a little review, adding and subtracting like-term variables. We're going to use the variable x. So we're going to look at this, and we have 3 minus 2x plus the 1 plus 5x. Now take a look. You have two sets of variables here, the negative 2x and the positive 5x. And then you have the real numbers 3 plus 1. You add like terms, so you're going to end up with 3x plus 4. Now this is fine when we're dealing with variables, but just to see if we can put this in the imaginary form of a plus bi, I being the variable like the x. So if we were going to use that format, we would have written this as 4 plus the 3x. So now we're going to go over here on the left, and we're going to do the add and subtract process for complex numbers. First we have the 3 plus 4i. Then we're going to go ahead and we're going to add a negative 1 plus 5i. Now remember, we want to use this as we do the same with like terms and variables. So we're going to now write this as 3 plus 4i minus the 1 plus 5i. And notice the 4i and the 5i are like terms, so we're going to add that, and we're going to go ahead and get 3 minus 1 is 2. So we have 2 plus 9i. Now, is this in the correct format of a plus bi? Yes, it is. So therefore, that is a good answer. All right, let's take the example of 6 plus 2i and minus 12 minus I. Now remember, we have the subtraction symbol in front of the parentheses, so that's going to change every sign in the parentheses. So to drop the parentheses now, we have 6 plus 2i minus 12 plus I. Now notice the variables, the I, 2i, and a positive 1i, and that's going to give us a 3i. And then we're going to have 6 minus 12 is going to give us the minus 6. Now, we'd normally say that's the answer, but it's not in the right format. It has to be the negative 6 plus the 3i. Now, that's in the format of a plus bi. Now, that's right. And that's your answer. Negative 6 plus 3i. If it's in the incorrect format on a test, it will be marked incorrectly. It has to be a plus bi. We finished the addition subtraction process. This is the multiplication process. Now, the minute I see that there's a complex number problem, I'm going to go ahead right away and write the chart I know. All right, so I have I to the 0, or we start with 0. And then I have I raised to the 1, I raised to the 2, I raised to the 3, and then I'm just going to fill them in. Anything raised to the 0 is 1. I know I to the first is I. And I squared now is going to be the same 1. the same I, but just negative. And what you need to remember is I equals the square root of -1. These are the two most important. And then also comes the I raised to the 0 is 1, that's what you start with. All right, before we begin, let's take a look how we treated variables. A variable x is the same as an I, all right? And when we multiplied, we had something like 8x plus 3x. You multiplied the coefficients, 24, and then the x times x. You ended up adding the exponents. So you dealt with the coefficients and then the variables. So here we go. Example would be the same one. 8i times 3i should equal also 24i squared. But we know that I squared equals -1. So we should have 24 times -1, and our answer is a -24. Easy, if you remember that I squared equals -1. All right, let's try another one. Here we go. We're going to multiply 7i times the 1 plus 5i. Now, this is distributive property. The same way you would do it if there were variables. Well, I is a variable. So we're going to have 7i times 1 is going to be 7i. And 7i times the 5i is 35i squared up. And there's I squared again. I squared equals -1. So you're going to get 7i plus the 35 times the -1. And we have 7i minus the 35. Now, is this in the right format? A plus bi? Well, it doesn't look it to me, so we have to switch it to be a -35 plus the 7i. Now, make sure you remember, if this is a -35, then it's a -35 here. Keep the sign with the numbers. All right, this is our last multiplication problem before we go on to division. Always remember to write your chart, starting at I to the 0, 1. The more often you will write this down, the faster you will remember it. So let's go over here to our example problem. Now you're familiar with this type of problem. You have two binomials. We've done this with x. You can either use a distributive property or you can go ahead and use FOIL. I'm going to use FOIL when I multiply. So I'm going to have 4 minus the 5i plus the 4i minus 5i squared. First, outer, inner, and last. We go ahead and we have 4, and we have the -5i plus 4i is a -1i. And then we have here the -5, and I squared is a -1. Don't forget the I squared. So now we have 4 minus the I, and we have plus 5. So we have a 4 and a 5, which is 9. 9 minus I. Is that in this right order? A plus BI? It certainly is, and that's your answer. Just treat your I's like we do any variable. The trick is to know that I squared equals -1 and to put it in the correct order. We're now going to divide using complex numbers. We have 2 minus I over 4 plus I. Now remember, I is actually the square root of -1. And we've always said in the denominator, we cannot have a 0 and we cannot have a square root. So when we dealt with radicals, what we did was we multiplied the numerator and denominator by the conjugate. And the conjugate of 4 plus I is now 4 minus I. And we multiply both the numerator and denominator by that. So just remember that when we talk about denominators, we cannot have 0 or square roots. And I is a square root. So therefore, the conjugate of 4 plus I is 4 minus I. And that's what we multiply by. Now when we go ahead and multiply now, we're going to multiply across, and we're going to get 8 minus 2i minus 4i plus I squared. And simplifying that, we're going to have 8, and this negative 2i and minus 4i is going to be negative 6i. And don't forget I squared is a negative 1. So I have here 8 minus 1 is 7 minus the 6i. Now, going down to my denominator, this looks familiar because it is. It's factoring of two perfect squares. If you remember, the middle terms disappear, the inner and the outer. They're exactly the same except for the sign. So you're going to actually get 16 minus I squared. Now I squared, remember, is a negative 1. So it's 16 minus the negative 1. So that changes the sign, the subtraction. So it's 16 plus 1, and you're going to get an answer of 17. So writing this now in simplified form is we have in the numerator 7 minus 6i, and in the denominator we have 17. And that is your answer. Main thing is to know the conjugate and simplify. Now, one other way you may see this written, if you wanted to write it actually in a true sense of a plus bi, you would take this answer, and you would go ahead and separate each thing, each item. So really 7 is over 17, the same way that negative 6 is over 17. So another way of writing this is 7 over 17 minus 6 over 17i. And that is in the true form of a plus bi. So either one of these is right, and if it's a multiple choice question, understand that the answer could be written in either one of these formats. This is the end of the video.